Hello, Algebra 2 folks, and welcome to Solving Absolute Value Inequalities. You need your notes, a pencil, and a calculator, and we will get started. So first we're going to talk about the things we already know, just to be sure we're on the same page. So absolute value is your distance from zero. It's always positive. Absolute value equations have equal signs, and absolute value inequalities have greater than or less than signs. So today, if I'm going to graph them and solve an absolute value inequality, does that change my approach on how I'm going to solve them? And I would say no, but the solutions are going to look way different. All right, so we are going to solve an absolute value inequality graphically. Okay, so what we need to do is we need to think about how we did this with an equation. Remember, we started with our we first started with our absolute value equation. The slope of this would be 1, and the vertex would be 2, 0. So we're going to start with a vertex of 2, 0. Okay, and graph my V. And then remember, we graphed the other part of the equation, and this time it's going to be inequality, but we're going to graph this part, which is the 4. Okay, so I'm going to come down here and get my blue color, and so we're going to graph where we have g of x equaling to 4. That's a horizontal line at 4. And remember, when we talked about where they were equal, we said they were equal here and here. And that number would have been -2 and 6. But this time I don't want the equal sign. I want where the absolute value, the red, is less than the blue. So if we go back to where they're equal, okay, where the red is less than the blue, you can see that the red here is less than the blue here and here. Okay, so between -2 and 6 is where the red is less than the blue, or the absolute value is less than the line. So if I were going to write that as an inequality, I would say that x is greater than -2, and x would also be less than 6. Okay, I could write that as one inequality as well. It would be -2 is less than x, which is less than 6. And I could write this in interval notation. And that would be from -2 to 6. And I'd use parentheses because I have a less than. If you have a less than or a greater than, you would use parentheses. Now, if I had a greater than or equal to or a less than or equal to, then I would use brackets. Okay, so that's how I would solve an absolute value inequality graphically. Let's do one more of those. Okay, let's start out by, again, splitting them up. Okay, and let's first graph the absolute value of x plus 1. That means left 1. Okay, and then my slope is 1, so I'm going to go up 1 over 1 on both sides. Okay, and remember, I'm not trying to find out where they're equal. I'm trying to find out where the absolute value is greater than 3. So, but I still need to graph both of them. So now I'm going to graph the line at 3. And again, remember, if we wanted where they were equal, it would be this x value here and it would be this x value here. But I'm not looking at where they're equal. I want to know where the red is greater than or equal to the blue. So I'm looking for where the red is above the blue. So where the red is above the blue is here and here. So over here or over here. And the reason why I'm going to use the word or here is because they're separated. Okay, when it was less than, it was kind of all together. So that would be and. But this time it's an or. Okay, so if I want to write the inequalities, I would say x is less than or equal to -4, or x is greater than or equal to 2. And if I want to write that in interval notation, I would say from -infinity all the way to 4 included, because we have a equal sign, greater than or equal to. Okay, and then or 2 included all the way to infinity. So this would be my interval notation, and this is my inequality. Okay, now we're going to take a look at how I would solve these algebraically. Okay, so we are going to do like we did with the equals. We're going to set them up into our two inequalities. The first one is going to be the positive slope, and the second one is going to be our negative slope. Okay, so let's go ahead and solve these. Subtract 5. 4x is greater than 8. Divide by 4. And x is greater than 2. Okay, let's do this one. I'm going to go ahead and divide by that -1. Oh, when we solve inequalities, here's where it's different. If we divide by a negative or a positive, you have to flip the inequality sign. So this is actually 4x plus 5, which is less than -13. Now I now have to go ahead and solve for x, just like I did before. So I subtract 5. I get 4x is less than -18, and I divide by 4, and I get -4.5. Okay, so here's my two inequalities. It would be greater than 2 or less than, greater than 2 or less than -4.5. And then if I want to sketch my solutions, I have to draw out a number line. Okay, here's 0, 1, 2, 3, -4, -5 here. So -4.5 is about right there. 1, 2. Here's where 2 is. Okay, so they got the negatives over here. We got the positives on the right. Okay, and if I'm going to sketch the graph, I would say x is greater than 2, so I'd come to 2. I'd make an open circle, and everything greater. Then x is less than -4.5, so I go to -4.5, and it's open circle, and I want everything less. And because I have two sides, one going in one direction, one going in the other, it is definitely an or. The interval notation would be from -infinity, because that's what that arrow is going to, -infinity, all the way to 4.5. But this time I'm going to use a parenthesis because I don't have an equal sign, or 2 to positive infinity. So here's how I would sketch it on a number line. This is my inequalities, and this would be my interval notation. Okay, let's try another one. So x plus 4 is greater than or equal to 6. So I've got to set it up into two different inequalities. So my positive slope and my negative slope. Okay, I'm going to go ahead and solve for x. X here is greater than or equal to 2. Over here, because I subtracted 4 on both sides, just to make sure. And over here, I'm going to divide by negative 1. So I'm going to have x plus 4 is, let's see here, going to flip my inequality because I'm dividing by a negative. So 6 divided by negative 1 is negative 6. And I'm going to subtract 4 from both sides. And I get x is less than or equal to negative 10. So now I have two answers where x is greater than or equal to 2 and where x is less than or equal to negative 10. If you can't decide if you put an and or an or, why don't you go ahead and graph the solutions on a number line. Okay, and we put 0 here. We might want to go by 2s, 2, 4, 6, 8, 10. So negative 10 is here, positive 2 is here. Okay, and we will use closed circles because we have the less than sign there. So we have greater than or equal to 2. That's everything that way. And we have less than or equal to negative 10. That's negative 10 and everything that way because that's where less than. So we have two arrows going in opposite directions, so that tells me it's an or. So it would be x is greater than 2 or x is less than negative 10. Now to write that in interval notation, negative infinity to negative 10. Remember the negative 10 would be included, and then the 2 would be included to infinity as well. Okay, I'm going to do one more, and this has a couple of different things going on. First and foremost, we need to isolate our absolute value, so we're going to subtract 5 from both sides. Once we isolate our absolute value, then what we can do is separate it into our two inequalities because we have a positive slope and a negative slope. So we have 2x minus 7 is less than 1, and 2x minus 7 is less than negative 1. Okay, so now we're going to have add 7 and solve these inequalities. In this case, x is going to equal 4. Okay, so x is less than 4. And then we're going to add, oops, I forgot the negative. Don't forget that. I got to take care of that and put the negative slope there first. Okay, and now we can go ahead and divide by the negative 1. And so we have 2x minus 7. I got to flip my sign is greater than, oops, this would be positive 1. I put my negative on the wrong side, I guess, when I wrote this equation. So let me start that again. Okay, I need that negative slope. And if I need that negative slope, I'm going to start this over so we have this right. 2x minus 7 in parentheses with our negative slope is less than 1. Okay, now we're going to divide by our negative 1. Sorry about that. It's really easy to mess up all those negatives, so be careful. I'm going to flip the inequality, divide by a negative. I'm going to add 7, and then I'm going to have 2x is greater than 6, and then I'm going to divide by 2, and x is going to be greater than 3. So I have x is less than 4, and x is greater than 3. So I don't know if this is going to be an and or an or. I don't know if this is going to be an and or an or. Sorry, I need to go all the way back. I accidentally exited out, just like I did there again. Going too fast here. Okay, so I'm going to go ahead and graph the solutions. Okay, on the number line. So here's 0, here's 1, 2, 3, 4. Go ahead and do 5. I want less than 4, so open circle, less than 4, but I want greater than 3. So then I want open circle, greater than 3. Notice how they connect between 3 and 4. So the solutions are somewhere between 3 and 4. So my interval would be 3 to 4 open circles. Okay, and you could leave it as the arrows that I had, or you can go ahead and graph it so that it's in between those two numbers. Okay, and so again, we are solving absolute value inequalities. We set them up just like we do equations, but our answers and our solutions look a little different. So make sure that you can sketch the solutions and write the solutions in interval notation. All right, that's all I have for you folks. Thanks for listening and taking good notes. We'll see you again soon.